Okay, so today is September 17th, and you're here for Econ 249. So I'm going to finish up with Chapter 4 today. Before we start, I want to remind you that your Excel assignment is due by the end of today. So I expect one person in your team to upload it on Blackboard. If you have not connected with your team as yet, then send me an email and we'll try to figure something out. But the Excel assignment is due today, and don't forget your homework is due on Sunday. Now, a reminder about your first exam, it's next week on Tuesday. It's set up exactly like your homework. So your homework has a few different questions with different parts. So that's the same way your exam is. You would access the exam in the same place you would access your homework. So that's through MyLab. The exam is open from 12:15 to 1:30 on Tuesday. So if you are in MyLab at 12:10, you will not see the link for the first exam. It will be visible exactly at 12:15. If you are on the site and ready to do the test at 12:20, you will be able to see it, but you would have lost 5 minutes. The best way to study for this test is to go over your homework problems. Now, if you have already completed the homework by the deadline, then you should be able to view all the past homework problems. The other way to study is to practice these problems through the study plan. So the study plan on MyLab is set up where they have similar questions to your homework. The scores that you get, I will not use towards your course grade. It's just for you to be aware of what you need to work on. Okay, so that's the study plan in MyLab. Also, you can view the PowerPoint slides and your notes. So I will not be posting a review sheet because the review is basically telling you it's the topics that we covered, chapters 1, 2, 8, 3, and 4. So that's on the syllabus. Okay, let's see. Any questions for me? Okay, how many questions will be on the test? And will the questions on the test be as long as the homework? So I'll answer the first one. The number of questions on the test doesn't really matter, because if I tell you 5 or if I tell you 20, it doesn't matter, because let's say question number 1 has 4 parts, question number 2 has 2 parts. It really depends. Chapter 4 and chapter 3 have a lot of quantitative stuff that you need to be able to do, and the earlier chapters have a lot of definitions. So spend your time wisely when you're studying. The other thing is you won't have time during the test to search for the answer. So if you are struggling with something and you're trying to find the answer, because I know you have PowerPoint slides available to you, the past homework is open, it's open book, right? You have everything available to you. So you won't have time to search for the answer. You should study for this as if you're taking the test in the classroom. Study for the statistics test, right? Practice those homework problems. I will not have questions on the test that take a lot of time. In today's lecture, I'm going to show you how to use Excel to do a lot of the calculations. So if you feel that it's a data set that is extremely large, just like the homework where it says copy this table onto Excel, you should be doing that. You should be using Excel to quickly get the answer, because that's the idea, right? I don't expect you to do it manually and take a long time. So Ying, you're asking me if chapter 8 is on the test? Yes. So I said chapter 1, 8, 2, 3, and 4. Okay, any other questions for me? No? No questions? Okay. Just making sure we have no more questions. Okay.
Oh, Professor, I
Yeah.
have a quick question.
Uh-huh.
So the test will be available at 12:15. but how would you send us the link for Zoom? Will it be on Blackboard Collaborate or just an email?
Yeah, so good question. On Monday, I will send you the link for Zoom. Um, some of you have told me that you don't have a camera on your laptop, and that's fine. You can use your phone to click on the Zoom link because I still need to be able to see you. And you can change your background if you wish, but I need to be able to see you while you're doing the test. So I will send that to you on Monday.
Okay, great. Thank you.
Okay, and if for some reason you're stuck in the middle of the test, your screen froze and or something is going on, you meant to type a certain number but you didn't, I'm going to be available from 12:15 to 1:30 during our class time. So you can quickly send me an email saying it's locked me out, something happened to my Wi-Fi, let me know. Things happen, right? But after the test, a couple of hours later, if you tell me, oh, I did something on this question and it should have, I'm not going to help you then, okay? So, have your email available with my email address ready so you're not wasting time on that. Yes, Gilbert, do you have a question?
Yeah, I remember last semester I took an exam on this MyLab, and I got a couple questions wrong by fractions or because I missed, I miscounted or something like that. Would you be hard on those?
So what happens is, just like the homework, the questions are set up with a certain tolerance with the second decimal place and the third decimal place. So once you start rounding from the beginning, it really messes up the final answer. Um, just be careful when the question is saying two decimal places, make sure you put two decimal places, otherwise it's going to mark you wrong. But to answer your question, I'm going to say, no, I'm not going to be harsh. If you think after everything's graded that it was unfair because you were off by the first decimal place, let me know and I'm ready to fix all that. Okay. Um, Urmila, you have a question. Can you send the Excel work? I'm not sure I understand your question. Can you use your microphone, Urmila?
Yeah, hi. So as you mentioned, you mentioned that we can use Excel to do our working. In such a case where like we're off like for some decimal places or whatever, can we send you the Excel?
Sure. If you have that as proof, yeah, that would be great. Yeah.
Okay, thank you.
Okay. Any more questions for me? No? Are you sure? Okay. So before we continue with chapter 4, in the last class on Tuesday, after we ended, a few of you stayed on, and we started talking. You asked me a couple of questions, and someone asked me where I was originally from, and then I said that I was from Sri Lanka. And then we have a student here who has a wonderful story about her experience in Sri Lanka. So Priscilla, I'm going to put you on the spot and you're going to give us a couple of minutes worth of a quick story, right?
Hi, yes. Thank you, Professor. Hi, everyone. Yes, I had an experience in Sri Lanka when I was only 16 years old. Um, I was like in a contest in Colombia, and I won a prize. The prize of that contest was a trip to Sri Lanka because one of the sponsors was from there. So we were supposed to do like events and pictures, photo shoots for a catalog, and I went with my mom because I was a minor. So we were supposed to be like on December 26th by the beach, and suddenly like we changed our plans like the day before, and then when we were just traveling, when we heard like on the news, like while I was traveling from, I don't exactly remember the place that we were supposed to be, but it was like by I think by the, let me see, western side of the island, and then
Uh-huh.
southwestern. And we were traveling back to Colombo, that was the capital, and we heard that the ocean was going backwards, and then like people and everybody started to like run. And then we saw in the news that just like a couple of minutes before, before we left, like everything that we had seen in a couple of minutes was destroyed already.
Oh
So
my goodness.
if we haven't left by that time, we would have been, I don't know, like maybe we would have been able to make it. And then like something funny that happened is that an aunt of mine, she had a dream of me like being on a wheelchair, and like my face was like with a big like anger. And then she called me,
Oh,
and then she said that to me, and I got so scared, but I didn't know what it meant until
oh my
the day
goodness.
after. So I feel like something happened in between, and I really thank God that happened, that we left before, because we had to go back. I mean, like the airports were all shut down. We were supposed to be there for a month. We ended up being there for 2 months because we helped the UK rescue members, crew members, and they were helping, like sending them food, sending them clothes, because everything like was torn apart and destroyed. Like all the
That
hotels that we
is,
have seen, like all the tourists, they were like most of them in a wheelchair, or like the hospital were like shut down, just like we have seen like before during the pandemic situation, but it was like way worse.
this is such an
Um,
amazing story. I mean, for those of you who don't know, in 2004, there was this tsunami in the Indian Ocean that almost destroyed a huge portion of Sri Lanka and Thailand. And so your family is okay with after all that they went through, Priscilla?
so yes, my mom was with me only, and then like everybody started like calling, but like all the communication were shut down, and we could only communicate like 2 days, or I think 3 days after that, and we let them
Mm-hmm.
know we were okay. But it really taught me a lot, because since I was kind of like modeling by that time, so like at that age you only think about materialistic things, but it really taught me, because it like taught me to serve other people like when they were suffering, and like packing up all the food. And it was like a very
Mm-hmm.
great like for me, I know like it was like a very sad experience for like the rest of the people, but when
Yeah,
you help, when you are in that situation to like be very productive, be like
yeah.
that person that can be there for them, like it really teaches so much.
Mm-hmm.
Yes.
That's a very motivating story. I mean, it's a good thing for all of us, right? Even though we're going through this pandemic, it could be a learning experience. So, a lot of the workshops that I have been in and meetings, they're always asking us, what's the good that's coming out of this? So, I agree, this could be a learning experience. For one thing, with us, I mean, just recording my lectures, I would never have been able to record it where you can go back and listen. So Priscilla, thank you so much. And this is what I miss in the classroom, that we can't share our stories, but hopefully one day we can meet in person and talk a little more, right? So thank you for that. I'm going to continue with chapter 4. Not as fun and not as interesting, but what to do? We do this, right? So I'm going to go to the last slide that we were at. Um, and in the last class, I think I left it where I was describing these terms, X and Y, and I said, don't get used to using X and Y, use it as an independent variable, the response variable. So that's where we stopped. Okay. And now we're going to start with the heart of chapter 4, which is actually correlation and linear regression. So you've heard of this term before. If something is correlating with something else, if there's correlation, it means that the two quantitative variables have some kind of a relationship. There's some kind of an association. So it's also called the correlation coefficient or the coefficient of correlation. It's denoted by that lowercase letter r. Now here's the formula, and it looks really complicated, but it's not. The numerator is really the sum of a product, right? And what's the product? So if I break it down here, my product is this times this. So I take every value of x, that's what the xi means, the first value of x, the second value of x, the third value of x. So take every value of x and subtract it from x bar. X bar is the sample mean, the average for all the observations in your x data set, times take every value of y, subtract it from y bar, which is the mean of all the observations in the y data set. And then you'd have the sum. So you take the sum of that product and then divide it by n minus 1. N is the sample size. And what is S? Does anyone remember what S stands for? Don't remember what S stands for? Not sample size, because N would be sample size. S is the standard deviation. Yes, Oscar. Yes, standard deviation. So S of X would be the standard deviation of all the observations in the X data set. S of Y would be the standard deviation of all the observations in the Y data set. But now that I've explained this formula to you, I'm going to tell you that you're not going to use it because you're going to be using Excel. So in today's class, I will spend time on how you're going to actually calculate correlation using Excel. But this sentence is important. Correlation measures the strength of the linear association between two quantitative variables. So you can't do this unless you are dealing with quantitative variables in X and Y, and you have a straight line, linear, straight line in your scatter plot. Okay, so moving on, before we talk about calculating correlation, let's look at the properties of correlation. So when you get a value, when you've calculated the value for R, your correlation, what does that mean? Well, if R is positive or negative, that sign gives you the direction of the association. So if R was a positive value, that means in your scatter plot, you would be getting a line that looks like this, going from the bottom left to the top right. If R gave you a negative value, then the direction would be negative. The next property is that correlation, that value that you calculate, it will always be between -1 and +1. It could be exactly -1, or it could be exactly +1, or it could be 0, but it's got to be between those two values. If the correlation that you calculate is exactly +1 or exactly -1, then that just means that all the points fall on the line in your scatter plot. Next property is that correlation treats X and Y symmetrically. So that means correlation of X with Y is the same as the correlation of Y with X. And also correlation has no units, because if you refer back to the formula, the units actually cancel out. So there are no units. The next thing about the correlation is that it's not affected by changes in the center or the scale of either variable. So if I take all the values of X and I switch it to a decimal or a fraction or a percentage, it's not going to change my correlation. Again, because the units are canceled. This next sentence is the same thing. It's just reiterating that it should be a linear association between the two variables. And then finally, correlation is sensitive to unusual observations. So if you have something that is an extreme value, remember in the formula, you're using the mean in the formula. So if you have an extreme observation, it's going to inflate your mean, which will affect your correlation and give you incorrect conclusions. Okay, so now let's look at correlation where you actually calculate it using Excel. And this is the method you're going to use if you have to calculate correlation in your homework. Okay, there are easier ways of doing this, but I'm going to show you this complete method, and then you can pick which method you like. So this is the example we're looking at. There are 3 columns. The first column is a population of individuals in the United States from 25 years to 64 years, taken in 2018. Okay, population. And these are the different population segments. Those that have less than a high school diploma, those that are a high school graduate, it includes a GED equivalency, those that have some college or associate degree, and then a bachelor's degree or higher. So the number of individuals in the United States in 2018 who had less than a high school diploma between the ages of 25 and 64 years was 18,249,663. Those who had a high school diploma was 43,815,706, and so on. Now the third column, employment rate. So 56.2% were employed and they had less than a high school diploma. 68.5% were employed and they were a high school graduate, and so on. Okay, so this is real data that was taken from the US Census Bureau. So reading the bottom here, the US Census Bureau collects data on educational attainment levels and employment rates. Now you're asked, are they correlated with each other? Is X correlated with Y? Is there a relationship between educational attainment and employment rate? So that's the question. So in other words, is education level strongly associated with employment rate, or do they have no relationship whatsoever? So I'm going to switch now to Excel and show you how to do this. But before I do that, I'm going to ask you, why do you think the US Census Bureau collects this data? Why do they care about the education level and what it has to do with employment rate? You can turn your microphone on if you wish. So why do you think educational attainment is necessary to know?
So I think that by looking at this data, they will estimate what is the employment rate. Like you can clearly see that the higher a degree or education level you have, the more likely you are to get employed. So it's important for the country to know that in order to react to it or do something about it.
Okay, I agree. So it's important for them to know how much of the country is employed and if employment rate is increasing because of educational attainment. Totally agree. Other things that they could use educational attainment levels for. So if not employment, let's look at educational attainment. Why would a country want to know that on a macro level? So this data, if you're interested, can actually, you can get into it and you can look per state, you can look per region, like mid-Atlantic states. So Haroon, you say for funding. So I agree. Government agencies look at this data for different funding allocations, for program planning, for implementation. Shubham, you say information about how students' education affects their employment in the market. Absolutely. So this information can also be used for universities to advertise, to determine the rate of employment by offering certain degrees. Oscar, you say to understand educational needs and provide equal opportunity. Absolutely. So there's something, and I'm not too familiar with this, but there is some requirement under the Voting Rights Act that that is based on educational attainment. So school districts are allocated certain funds to provide certain basic skills to adults who have not completed high school. So also to understand the literacy rate of citizens in the country. So all this information is used in many different ways. So it's important, right? Okay, so now these are the steps I'm going to use in Excel. So I'm not going to go over it in detail because I'm actually going to show you, but this slide is here for you to refer to it because I'm just letting you know right after the first exam, you're going to be working on Excel number 2 with your team. And this is where you're going to refer to, right? This slide on how to do all the steps that I'm going to show you. So step 1 just says type your data into the worksheet in Excel. So let's do that. So I have, I'm going to share my Excel screen. Does everyone see this? Okay. So now it's the same table that you saw before. You don't have to put all your X values in the first column and your Y values in the second column, but if you can, sometimes it's just easier to organize. But that's the first thing, right? Type your data or download your data, whatever it is. So we've done step 1. Step 2 says click the data tab and then click data analysis. So this is my data tab right there. The thing is, I have this function showing up called data analysis, which I have to click on next. If you don't see that function in your Excel spreadsheet, it doesn't mean that you don't have it. It just means that it's hidden. So you have to make it visible, and I'm going to show you how to make it visible. And these instructions are also on the PowerPoint slide. If you're using Google Spreadsheets, there is a different way of doing this. I'm really not sure how to make that data analysis function visible. You might have to Google that. If you don't have Excel and you're using Google Spreadsheets for all this, that's fine. But I just want you to know that as a student of Queen's College, you can freely download Microsoft Office. It's a free license to you. That's one of the benefits of having this license through Queen's College, that students access it for free. So you can have Microsoft Word, Microsoft Excel, all that stuff. Okay, just making sure I'm reading all the comments here. Yes, so what did I want to say? Okay, so I have to show you how to make data analysis visible. So if you click on data and you don't see data analysis function, this is how you make it visible. You click on File, Options, Add-ins. So once you click on Add-ins, okay, make sure this says Excel Add-in, then say Go. And then you want to make sure that both these boxes are checked, Analysis Toolpack and Analysis Toolpack VBA, and then say OK. So I'm going to exit out because for me it's already showing. Okay, so that's all it is. So now I'm going to click on Data Analysis and I'm going to click on Correlation because that's what I'm asked to do, right? Correlation. And I say OK. So it's asking me for the input range. It's basically all my values from X to Y. So I highlighted my XY range. It is grouped by column, so I don't need to change anything. Labels, because I do have a title column in the first row. And yes, I want a new worksheet output. I want it in a new worksheet. Okay, and that's it. So this is what you would do even if you had to calculate correlation in your homework. And I'm going to exit out because I've cleaned it up in a separate spreadsheet. I'll show you. So it will pop up and it will look, not this table, okay, remove that. It will look like this. So this is what your correlation output will look like. It will come up in a new worksheet and you have it here. And this is the answer for correlation for our example. R equals 0.973 if I rounded it up. R equals 0.973. Now I'll talk a bit about that, but for now, I'm also going to create a scatter plot and then discuss it, okay? So going back to my data, very simple. Remember, to create a scatter plot, the first thing you have to do is highlight your data. So I highlight X, Y, and I include the titles. Then I insert, and this is my scatter plot chart. So I would click on that, and immediately, oops, I have that. Now I'm going to actually go back here and show you the plot that I had before, because it was cleaned up and easily viewable with the two. So this is it, the scatter plot and the correlation. Okay, so now let me go back to our PowerPoint slides, because it actually shows you what I want to talk about. So I'll stop sharing, go back here. Okay, so this is what I just did. And then these are the results. So we have correlation and we have the scatter plot. So I said that one of the properties of correlation is that the value should be between +1 and -1. So that's right. R is equal to 0.973. Another property was that the sign of the correlation is the same, indicates the direction on your scatter plot. So in this case, the sign is positive, which means that our scatter plot is going to move from the bottom left to the top right. Okay, any questions for me before I continue? So now I'm going to ask you, what do you think the answer is? So I'm not going to do a poll, but since we calculated R, and I'll write it on top here, R is equal to 0.973. So what do you think the answer is for this? For the value of R that you just calculated, the relationship between X and Y is what? Okay, so most of you say A. Okay, so let's think about it, right? This is giving me a lot of information when I get a correlation coefficient. First of all, it's positive. R is not negative 0.973, it's positive. So that means I only have two options. I can eliminate two answers. This is negative, this is negative. It can't be this. If R is close to 1, it's strong. If R is close to 0, it's weak. Okay, I'll say that again. If R is close to 1, it's strong. If R is close to 0, it's weak. If R is close to 0.5, we say it's moderate. There's a moderate relationship. So now this is the correct answer. Yep. Strong and positive because it's close to 1. Okay. And this next slide actually visually explains what it is I mean by close to 1 or 0. So let's start with when R is equal to +1. So R is positive. That means my scatter plot is going in the positive direction. But because it's equal to 1, all the points are on the line. So we have a straight linear relationship. And it's a very strong relationship, very strong positive relationship. When I look at R is equal to -1, it's in the negative direction, and all the points are on the line because it's equal to 1, -1. Next thing, when R is equal to 0, that means there is no relationship. There is no association between X and Y. Now, when R is equal to +0.3, Okay, I'm here now. When r is equal to positive 0.3, first of all, it's positive, so that means the direction of my scatter plot is going to the positive direction. 0.3 is close to 0, so it's a weak relationship. There's a weak association between x and y. When r is equal to negative 0.6, negative, the direction is negative, but it's close to 0.5, so we would say a moderate. So a moderate negative relationship. Questions for me? No questions? Okay, so if I asked you with our value of r equals 0.97, I think it was 3, rather than saying x and y, get used to actually using the variable term, right? So there, we're saying there's a very strong positive relationship between educational attainment and employment rate. That means educational attainment has something to do with employment rate. It's quite significant and a very strong relationship between the two. And it's positive. So we can see that it's almost a linear line, which means that as x increases, y increases. As educational attainment levels increase, employment rates increase. What about this? And this I'm going to do as a poll. Okay, so the question says, what if you had a different problem and if r was equal to 0.188? What do you think the relationship would be? So I'm going to give you a poll. Hold on. And then you can answer it there. So if r is equal to 0.188, is it between calories consumed and weight loss? Or is it between hours of sleep and score on a test? Hours of sleep and score on a test, or calories consumed and weight loss? Okay, 10 seconds. Okay, so most of you said B, and B is actually the correct answer. So, okay. Who wants to explain why why you didn't choose A?
Okay, so I chose B because 0.188 infers a positive correlation,
Okay,
but a weak positive correlation.
agreed. Okay,
Therefore, when you sleep a lot, your score and test should be higher. There's no promises. There's plenty of cases where you can get a lot of sleep and do poorly on exam, and there's plenty of cases where you can get almost no sleep and do well on exam. However, if you consume more calories, you're not going to lose weight, because if you consume more than you lose in calories, you automatically gain weight.
perfect. Yep, I agree. So
So
there's no way that A could be the answer, because if I keep increasing calorie consumption, then I cannot increase weight loss. So that would not make sense. So for that reason, we chose B, hours of sleep and score on a test. It's a weak relationship. So why? So you mentioned a little bit that it's not a perfect correlation. It's a weak correlation, because other factors could be involved. It's not just hours of sleep that makes you score high on a test or increase your score on a test. There are other factors that are involved. So that actually brings me to something I want to mention, and it's not on the slide. So I'm going to share a blank whiteboard and I'll just draw on it. this is my X and Y axes. The X axis is doctors per person, and the Y axis is life expectancy. Life expectancy. So let me give you some background first. The average age of men and women in years for 40 different countries is taken. So the life expectancy, we're taking the life expectancy in 40 different developing countries. And it's actually the average age of men and women. Okay, so that's all our Y values. The X values is the number of doctors per person in each country. So the number of doctors per person in each country, that's my X values. Now, so I'm going to have 40 countries, so I'm going to plot those 40 points, and it would look something like this. Okay, so I'm just kind of plotting it here, not very accurate, but this is the idea. So this is how my plot would look like. So, and let's say I calculated the correlation coefficient and I found out that R is equal to 0.705. So now what can you tell me about the life expectancy and doctors per person in these 40 different developing countries? So it's not a trick question. It's probably exactly what you think. Luke, yeah?
So there is, if you're just basing it off these two variables, there is a strong, I tend to think there's a strong relationship between the two.
Okay, I agree. And I see a lot of you say the same thing here. So Gilbert, as you say it more precisely, the more doctors, the higher life expectancy. Okay, so if I had to draw a line through these points, it would probably look something like this in the beginning, right? So as I keep sending doctors to these developing countries, the life expectancy will increase. Or if more doctors graduate in those countries, the doctors per person increases, the life expectancy increases. But then at some point, it kind of levels off and it says no matter how many doctors I keep sending, the life expectancy stays the same. So that means there's something else going on here. And I'm going to bring your attention to this term called lurking variables. So a lurking variable is something else that's going on. So let's think about this, right? Is it really the number of doctors per person that is increasing life expectancy? Well, Priscilla, you say that people might not have access to health benefits. So maybe the health situation needs to be fixed. In other words, the standard of living, because health is included in standard of living. So there are other factors that are included that increases a person's life expectancy. So a higher standard of living could be that lurking variable. Lifestyle also contributes. Education, um, diet. So all this is important to increase life expectancy. So the point in this slide is to remind you to resist that temptation. Don't just conclude that, okay, correlation is 0.7. It's strong. It's a great relationship because sometimes X might not cause Y, no matter how obvious that conclusion is. There might be lurking variables, a variable other than X or Y that affects both, which actually results in this correlation between X and Y. So just be aware, sometimes we have to rely on common sense as well. Okay, so moving back to our chapter 4 slides. Exactly, Christopher. Correlation is not causation. So I just wanted to briefly mention this. There are many studies that have proven this, but for our class, I don't have time. So I'm moving on to, so this is where we ended, I think. Checking. No, we went further down. We were here. Actually, we were at the next one. Okay, so this is where we ended. So now I have not shown you how to actually fit a line through the scatter plot. I'm just asking you to imaginary draw a line through it. So that's what we're going to look at now, this linear model, how to draw a line through the scatter plot. So this is a new example. It's telling you the relationship between Amazon's book prices and the weights of the books. They found out what R is, the correlation coefficient. They found out that R is equal to 0.498. So the relationship is moderate, positive, and linear. Okay, so the x-axis is the weight of the book given in ounces, and the y-axis is the price of the book. Okay, so again, there's no line, you're looking at a plot. So we can model the relationship with the line, and we can actually give an equation. So the linear model, it has this complicated name, but it's just an equation. That's all it is. It's a straight line through the data. Now we understand that all the points are not going to fall exactly on the line, but we're going to draw it in such a way using this special equation where the distance from the points to the line are minimal. Okay, so this is what it would look like. And how do we come up with this? We use this formula. So you have seen this before in a previous math course, I'm sure. This is the formula we use to draw a straight line. Y equals B0 plus B1x. But we're going to do it slightly different. We're going to call it Y hat. Y hat equals B0 plus B1x. The hat on the y just means that it's a predicted value. It's the same idea, but y hat is a predicted value. Okay, this next slide is the most important slide really for this chapter. It talks about residuals, the line of best fit, and linear regression. So a linear model, I said, is basically an equation, right? So it's written in this form, y hat equals b0 plus b1x. B0 and B1 are numbers estimated from your data set. So Y hat is called the predicted value. B0 is called your y-intercept. And B1 is called your slope. The difference between the predicted value and the observed value, so the observed value is Y. That difference is called a residual, and that's denoted by this lowercase letter e. So for me to calculate residual, I take the observed value, which is y, minus the predicted value, which is y hat, and I can get the residual. So this method is called the line of best fit. It's the line for which the sum of the squared residuals is the smallest. We call it also the least squares line. So again, recalling this method is used because it gives you the least distance from the points to the line. So this least squares line is sometimes called a regression line. And you've heard that before. So regression lines, the line of best fit, using a linear model, they're all the same thing. So now before we start crunching numbers and trying to figure out what y hat is, what b0 is, what b1 is, residuals, and I'll do all that on Excel, let's try to continue with our Amazon example with the book price and the book weights and interpret the slope and the y-intercept first. Okay, so let's do that. So here they have figured out the linear model, the equation. So again, I have not shown you how they came up with this equation, and I will do that with you. but they did this already. So so let's start from the top actually. Y hat is my price. So that's Y hat equals B0 is 10.35 plus B1 is 0.77 and X is the weight. Okay, so that's our linear model. Y hat equals B0 plus B1X. So the first question asks you, what is the explanatory variable? So who wants to answer that? What do you think the explanatory variable is? So these are terms that we discussed in the previous class.
The weight.
The weight is your X value, which is your independent variable. Correct. Yep. So I'm going to say X, but when you answer it, yes, you should say weight, the independent variable. And then the response variable would be Y. Y is your dependent variable. Y is your response variable. Y is price, the list price of the book. Okay. Third question, what does the slope mean in this context? So here, the slope is B1, which is equal to 0.477. So it's not enough just to give me the value. This is where you have to give the interpretation of the slope. So this is how you would interpret slope. For each additional unit in X, this is how much Y changes. I'll say it again. For each additional unit in X, this is how much Y changes. Okay, so now I'm going to reword that using weight and price. For each additional ounce in weight, for each additional ounce in weight, the price of the book increases by $0.477. The price of the book increases by $0.477. So increases because 0.477 is positive. And I have to be sure to use the units that are given here. Questions about the interpretation of slope? No? Okay. Then moving on, is the y-intercept meaningful in this context? Okay, so first let's figure out the y-intercept, interpret it, and then answer whether or not it's meaningful. So the y-intercept is our B0 value, which is equal to 10.35. Okay, so that's the y-intercept. Now let me give you the interpretation for the y-intercept. When x is equal to 0, this is the value of y. When x is equal to 0, this is the value of y. So when the weight of the book is 0 ounces, the price of the book is $10.35. Now, is this meaningful? When the weight is 0 ounces, the price is $10.35. Karina, you say it could be a starting point. So $10.35 could be like a base price, a starting point, no matter what the weight is going to be. Okay. So you say, yes, it is meaningful. Christopher, you say no, because there are prices lower than 10. Prices lower than 10. Okay, I see. So Christopher, you're looking at the graph, at the scatter plot, and you see that when the weight is 0, no, let's do it the other way. You're looking at the scatter plot, and when the price is $10, and let's say 35 cents, there are prices that are less than $10.35 with an increase in the weight. So you're saying it doesn't seem meaningful. Okay, so as long as you can explain yourself like this, I'm fine with it. So you could say, yes, it is meaningful, because what if it is a digital textbook and there's no weight, and or $10.35 is the base price, or no, it doesn't make sense because the graph is showing me something else. Okay, either one is fine, but you need to know how to interpret your slope and your intercept. So continue with the same problem. The next question is saying, consider, for example, Peter Drucker's book, Innovation and Entrepreneurship. According to Amazon, the book weighs 6.4 ounces. What is the price you predict? Now, going back to our linear model, remember price is y hat. Okay, that's a hat on top. Let's erase that and start over. Price is y hat, and that's equal to b0 plus b1 x. So this is saying y equals 10.35 plus 0.477, and the book weighs now 6.4 ounces. So what should my predicted value be? 1340 is what Shubham says. Okay, so let's go with that, 1340. So that's what I predicted to be using my linear model. Now it tells me that, in fact, the book's list price is $16.99. So for Drucker's book, what is the residual? Okay, I know for residual, I have to do observed value minus the predicted value, which is observed value is $16.99 minus the predicted value of this. And Dong Yang and Danielle, you say it is $3.59. That's my residual, E. Okay. One more thing you need to note. When your residual is positive, that means you have estimated your value. You underestimated that predicted value. If your residual is negative, then you have overestimated that predicted value. Okay, any questions for me? Okay, so I still haven't shown you how to actually come up with the B0 and B1 and how to come up with this linear model. So that's what I'm going to do now. Okay, so moving on to the next slide. Let's start with slope B1. Now, if we were in the classroom, you would have to do this manually, where you pull out your calculators and you calculate the slope. So you can see here it's correlation times standard deviation of all the y values, standard deviation of all the x values. And here's your interpretation. So this is a good slide to study. With each additional unit of x, y increases or decreases by whatever sign B1 is. And but I'm going to show you how to do this on Excel. The y-intercept is this formula. Again, if you were doing it by hand, you take the mean of all the y values minus your B1, the previous slope value that you get, times the sample mean of all the x values. And again, the interpretation. Oh no, this should say when x is 0, y is. So I'm going to correct that. It shouldn't be when y is 0. It's when x is 0. So you have to fix that. I just noticed that. When x is 0, this is the value for y. Okay. Okay, so now I'm going to use Excel and we're going to come up with our linear model. Okay, so going to the next slide. Going back to our example. So we have the population of individuals from 25 years to 64 years, educational attainment, and employment rate. So the first thing you need to find the slope and the intercept for the line of best fit. So that means you have to find B0 and B1, and then you have to interpret them. Then you need to write an equation to predict y hat. So that y hat is missing over there, but you have to write your linear model equation. And then you're asked, What if you add a master's degree or higher to this data set? And you're told that we know that 28,700,000 individuals have a master's degree or higher in the US in 2018. Now, what do you think the employment rate would be? Okay, so that's what I'm going to do. And I'm going to do it on Excel. When you're doing this for your next Excel assignment, these are the steps that you would follow. But I'm not going to read through this because I'm actually going to show you. Okay, so now I'm going back to our Excel spreadsheet and sharing my Excel with you. Okay, so going back to the data set, this is where we were. First thing is go to the data tab and click on data analysis. Now you know already what to do if you don't see that function, right? Okay, so click on data analysis. Then scroll down to regression because that's what we're doing right now, regression. And then say OK. First thing is the Y input range. So I'm going to go straight to my Y input range and I'm going to highlight the values that I need. I am including my column title. And then it's asking me for the X input range, and I'm going to do the same thing. That's my X. I'm saying, yes, I have labels in the first row. Then I want my output in a new worksheet, and I would like residuals. So I'm going to click on residuals. Okay. And then I basically say, okay. Any questions before I continue? Let me see. Paul, you asked me how do you get data analysis? It's in the instructions in the previous slide, okay? It's in slide 15. Okay, so you can go back to slide 15 to get the instructions for that. Okay. Going back to the Excel spreadsheet, and then I say, okay. So right now I'm not going to say okay because I already have the data. So you would say okay. I'm just going to exit out and show you what it would look like. This is what you would get. Move this here. So let's scroll up to the top of my sheet and explain to you what it is we're looking at. Okay, so that multiple R is actually your correlation coefficient. That's the value for R. So you wouldn't even have to do correlation through data analysis if you did regression because you're getting that anyway. So correlation is 0.973. If you're interested in what R square is, it's actually called the coefficient of determination. How many points actually fall on the line? We're not going to use it for this class, but it's there if you need to know. It's also telling me that I have 4 observations in this data set. Remember, we looked at only 4 education levels. This table, the ANOVA table, I will not be using it for this course, but if you take econometrics or Econ 382, you will be referring to the ANOVA table. This stuff in the green is what we're interested in, the coefficients, because the y-intercept B0 is negative 579,62243.26. The slope B1 is equal to 1414066.407. Okay, so I immediately get my answer. If I go further down on this spreadsheet, I can see my residuals. So it's the difference between the independent variables and the predictors of the dependent variables. So it's giving me each of the residuals if I wanted it. Okay, so I have all the information I need. I can use that information and type up my what's the word I'm looking for? My linear model. So y hat, which would be employment rate equals Let's fix that spelling. Okay. Employment rate equals B0. So now B0 is negative 579,626,22443.26. B0 plus B1, and B1 is 1414066.407 times X, which is educational attainment. So that would be my answer for my linear model. And if I had to interpret B0 and B1, so let's start with B0. B0 says when X is equal to 0, this is the value of Y. So when educational attainment is 0, employment rate would be negative 57962, so on. Okay, maybe it's not meaningful, but that's how you would interpret it. If I have to interpret slope B1, it's telling me for each additional level of education attainment, my employment would increase by 1414066%. Huge number. Now we're told, what if you added a master's degree or higher? And what if we know that the amount of individuals with a master's degree or higher was 28,700,000? Then what would the employment rate be? So that's how you would do that. Okay, and you would get your predicted employment rate. Now you're also told to add a trend line. So I'm going to show you how to do that. It's very simple. If you go back to your scatter plot, you're just going to add a trend line. You're going to add the line to the plot. So I would select the points and I would right click, add trend line. So it's automatically drawing that straight line for me. I want to make sure I have a linear line. Let me move this. And I want to, let's scroll down a bit. I can display the equation on the chart. So if I click on that, it's going to give me the linear model immediately on the chart. And I already did that, so I'm going to show you that this is how it would look like. So there's your linear model. Any questions for me? So I'm just going to go back to sharing the slides because it has the same thing there. Okay, so here we are. Okay, so these are all the instructions that I just did. And this is the results that you saw in Excel. So you added a trend line and you were able to display the linear model equation. No questions for me? Okay, so the last thing for this chapter is something called covariance, and it's the same thing, does the same thing as correlation. So if it does the same thing, you might be asking, then why are we studying it? Why not be satisfied with regression and correlation? Why do we had to add one more thing? Well, in statistics, we use many different methods to make sure we're getting the same answer so that there's nothing wrong going on. So if correlation is telling me it's a strong relationship, then covariance should also tell me that it's a strong linear relationship between the two quantitative variables. So again, no point spending time on the equation. You're going to be using Excel, same thing, data analysis, covariance, and you've got your answer. But the value for covariance, if the value is greater than 0, so I'll make it a point to show you here. If it's greater than 0, then that means as X increases, Y increases. if x is less than 0, then they move in opposite directions. So when x increases, y decreases. When covariance is equal to 0, that means they are independent and there's no relationship. So there's no association between x and y. So this is the end of this chapter. This is basically what we spend time on. And this is what you should familiarize yourself with when you're doing the homework and you're studying for the test. Okay, so again, you have open access to all this stuff. Make sure you're able to use Excel. Don't try to figure it out during the test. You are not going to have complicated data sets. However, if you think something is taking longer than it should, you're probably doing it wrong. Okay, I'm finished for today, but I can stay on if you have any particular questions.
Professor, on the test, since we're going to be in Zoom, if we have a question, like we don't understand one of the questions, can we ask you or?
You will have to email me.
Okay.
Okay. Abraham, you say for the Excel group assignment, does it have to be submitted as a Word document? It doesn't have to be. I would like it to be copied and pasted onto your Word document and then submitted through Blackboard. Okay, for those of you who are leaving, you're welcome. Enjoy your weekend. I'm stopping the recording.